Now we're looking at problem number 3 from the MSP practice test, and in this one we're looking at a set of parallel lines. So these lines are considered parallel. Line P and line O are parallel, and they're cut by these lines, which are called transversals. So we have transversals here, and we have parallel lines here. And what happens when you have parallel lines cut by transversals, you create all kinds of different angles and angle types. Like this one here, which is 58 degrees, is actually the same size as the angle right in here, which is also 58 degrees. They're called opposite interior angles when you have parallel lines cut by a transversal. Now that's helpful because in this question you're asked to figure out which angle is 153 degrees. And it should be a little obvious that 153 degrees is a pretty big angle. These are small angles, 27 and 58, and I can actually tell just by the way the picture is drawn that these numbers are not necessarily accurate to the actual size of the angle. So we're going to have to, instead of measuring with a protractor, we're actually going to have to remember some rules of geometry to find the measures of the actual angles. Now one of the things you know is that the line P, this line, which is a straight line, has to have an angle measure of 180 degrees. 180 degrees is the measure of a straight line. So if you take the 58 plus whatever this angle is, number 1, plus the 27, those three together have to add up to 180 degrees. So I can just subtract this from 180 and this one from 180, 58, and 27 from 180, so I'll pull out my calculator here, and because we want to find the measures of all these angles. So if we take 180 minus 58, and then again minus another 27 for the other angle here, then we get the measure of angle number 1, which is 95 degrees. So that's not the one we're looking for, but good to know to be able to find that if I might have been asked a question about that one, how to find that one. These three together add up to 180, and so that's the missing part of that. Now again, we found this angle, which is 58, which is an alternate interior angle, but then it also gives me the measure of angle number 3, which together these two have to make a straight line, which is 180 degrees. And so I can find angle number 3, which looks like a pretty big angle. Maybe that's the one I'm looking for. If I subtract the 58 from the 180, which would make up the two combined into a supplementary angles that add up to 180 degrees. So if I go 180 minus the 58, 122 degrees is the measure of angle number 3. So that's 122 degrees. Together they make 180, so that's not the one I'm looking for. And I know that angle number 2 is not going to be 153 degrees. It's very small. In fact, it's the same as this angle because it's vertical to it. So angle number 2 is 58 degrees. So that only leaves angle number 4. Now let's just make sure that we can prove that angle number 4 is the right size, because I can take this angle right here that's 27 degrees, and remember that it's alternate interior angle. You have a set of parallel lines and a transversal that cuts them. The alternating interior angles are the same size, so this one's 27 degrees, and together all the way across here is going to have to be 180 degrees. And so I think if I take 180 degrees minus the 27, and then I will get 153 degrees for angle number 4, and that's the angle we were looking for. So the correct answer here is angle number 4 is 153 degrees. And it's helpful to remember some of the rules of parallel lines that are cut by transversals that give you alternate interior angles that are the same size. So those two, the 58 degree ones, are alternate interior. The 27 degree angles are also alternate interior angles. And so that's helpful. And then knowing supplementary angles, or angles that add up to a straight line, can help you find the missing parts and pieces of parallel lines.